Grub is the default bootloader in most Linux distribution. Grub2 has an option to encrypt the bootloader. This reduces the attack surface against physical attacks by encrypting Grub Stage 2 and kernel RAM disk. These steps I'm about to show you are specific to Debian Jessie, but should work on most distributions. Make sure you make a backup, maybe even try this on a virtual machine first. What you can see here, this is what the partitions and LVMs look like after you have chosen to use encrypted LVM via the install on Debian or on Kali, and probably on other Linux distributions as well. It'll look the same or similar. So first we need to copy the files from the boot partition. We'll need to switch to root to do that. So I've created this here. We're copying everything from /boot to /mount_boot. We're copying everything from /boot VM-liners with the wildcard to mnt-boot. We'll diff those two to make sure there's no differences, and there isn't. And let's unmount mnt. And let's look at our disk again. And we can see it's back to normal. We need to prevent the /boot from mounting as we no longer need it. So we need to edit the FS tab. And on here, there it is. So Control K, get rid of that. Save this. Let's make a backup of our grub config file. Then we need to generate a new grub config that loads the appropriate modules. So we'll do that with this command. Then we need to reinstall the grub bootloader with grub enable crypto disk equals Y in the etc default grub file. Let's check that out, and we can see it's there. And let's run grub install on the disk. And there we go, installed, no errors. So now we should have our Grub2 encrypted bootloader. Let's reboot to find out. And here you can see we're asked for the master password. So this is the same password we've set up for the encrypted disk. And then we ask for the password again for the rest of the disk. And there we can see the new layout with the encrypted bootloader. To step it up a notch again, multi-factor authentication could be good to add. You can have YubiKey. There is a GitHub package here that will enable you to do that. Check out that, it's pretty good. Quite easy to do. Just run this command basically. You could also, if you like, move that partition instead to a USB or another device, meaning that your boot partition is no longer local to your device, and then you keep that USB somewhere safe. This can mitigate bootloader attacks, just as encrypting the bootloader can. But putting it on USB means you're putting everything on USB. Same process, but essentially you just put it on the USB. And there's an interesting read on it here, which was published quite a while ago. But ultimately, if the attacker can physically access the computer hardware, the device, then meddles with it, and you use it after, you're in trouble. Because the adversary, for example, can just simply attach a malicious component just as simple as a hardware keylogger. They don't even need to try to mess with your bootloader. So these are all just best efforts in that case.